Hey there, what's up? I'm Brett, and welcome back to Math Hacks. Today we are discussing factorials. I'll be explaining exactly what factorials are, showing you what type of problems they tend to show up in, as well as some fast and easy techniques for simplifying factorial problems. Factorials have this fun little notation. It is the exclamation point, and what it means is to take the number that the exclamation point is on and to multiply it by each integer descending down to 1. So for 5 factorial, that would look like 5 times 4 times 3 times 2 times 1. And of course, if we multiply all that out, we get 120. So that's pretty straightforward there. Now where factorials get confusing is when we start introducing multiple factorials together as well as variables. And that's what we're going to really spend our time looking at today. Now the good news about factorials is because we're using multiplication, we have a lot of really handy canceling techniques we can use that will make the arithmetic a lot simpler. So when you look at this and you think, oh my gosh, I've got to multiply 6 times 5 times 4 times 3 times 2 times 1 and 8 times 7 times 6 times 5 4 3 2 1, and that sounds like a whole lot of multiplication. Don't worry, because actually these simplify really nicely. So let's start by expanding out 6 factorial and 8 factorial. We have a lot of canceling that we can do. So if I look at this, I can cancel out the 2's, and well, the 1's obviously, the 3's, 4's, 5's, and 6's. So because each of these pairs divided to 1, I was free to cancel those out, which meant that all I have left is 1 over 8 times 7. And the 1 is just a placeholder since I canceled everything in the numerator. Now there's an even faster shortcut we can use to simplify 6 factorial over 8 factorial. I already know that 6 factorial on top is going to cancel out with the equivalent 6 factorial here because I have 6 times 5 times 4 times 3 times 2 times 1. So instead of writing all of this out, I could simply just leave 6 factorial in the numerator and write 8 times 7, and then instead of writing 6 times 5 times 4 times 3 times 2 times 1, I can just write that as 6 factorial instead. And then I can see that I cross out 6 factorial over 6 factorial. So when those cancel, see that we're left with 1 over 8 times 7, which is 1 over 56. So you see that we get the same answer either way. So this idea of expanding the larger factorial down to the smaller factorial is really important when we move into some harder problems here involving variables. Now, a place where you commonly see factorials show up is in combinatorics. So let's go ahead and do the combination formula. So let's say I have 8 choose 5. When I apply that formula, we get, and I'm just going to go ahead and do this 8 minus 5 to get 3 factorial. Alright, so now instead of multiplying everything out or expanding it all and canceling, let's see if we can cleverly cancel out some things without having to write a whole lot down. So what I'm going to do here is I'm going to look for my largest factorial. So I have an 8 factorial in the numerator, and my second largest factorial is 5 factorial in the denominator. So 5 factorial is what we're going to try to get rid of in this problem. And to do that, we're going to take 8 factorial and expand it down to the 5 factorial. So I'm going to take and write 8 times 7 times 6, and then instead of writing 5 times 4 times 3 times 2 times 1, I'm just going to write 5 factorial. And then I'm going to take the bottom as is. Okay, so that's really handy now because we can go ahead and cancel out that 5 factorial over 5 factorial. So now we are left with 8 times 7 times 6 in the numerator. And in the denominator, we have 3 factorial. So I'm going to go ahead and expand that. So I get 3 times 2 times 1. And now the last thing I would do from here is just to reduce any convenient numbers. So I see I have a 3 and a 6. So I'm going to go ahead and divide 3 into 6 twice. And I have a 2. I could either cancel out the 2 here, or I could reduce the 8. I'm going to go ahead and reduce the 8 because that sounds like fun. So now for my answer, I have just 1 on the bottom, so I don't need to worry about the denominator. And in the top, I have 4 times 7 times 2, which gets us 56. All right, the moment you've been waiting for, let's try to do some with variables now. So let's apply this choose formula again. This time let's do x choose 2. So I have a variable in it that I need to work with. And I'm going to set up the formula just like I did here, but I'm just going to use the variable x in place of the 8. Similar to our last problem, I'm going to look at the relationship between the values that I have, and I see that I have an x factorial and an x minus 2 factorial. So x factorial is definitely 2 larger than x minus 2 factorial, so I know I'm going to start there with my canceling. Now, even though I don't know the numbers, I can expand the x factorial because I know that I'm going to just descend by 1 each time. So that's going to look like x times, and then I'm going to put parentheses here and do x minus 1 times x minus 2, and I could keep going, x minus 3, x minus 4, and so on, but because I have an x minus 2 factorial in the denominator, I'm going to stop right there and just leave the rest of it as x minus 2 factorial. Now I can cancel out the x minus 2 factorials, and I'm left with x times x minus 1 over 2 factorial, and of course 2 factorial is just 2 times 1, or 2. So for the next problem, we're going to try a slightly more challenging variation. We're going to simplify x plus 2 factorial over x minus 1 factorial. Again, I'm going to look at the relationship between the two to determine which is larger. The x plus 2 factorial will be larger than the x minus 1 factorial. So I'm going to want to expand this one down to x minus 1 factorial. Notice to expand x plus 2 factorial, I simply had to subtract 1 each time from the constant. So I started with x plus 2, I subtracted 1 to get x plus 1, I subtracted another 1 to get just x plus 0, or x, and then I subtracted 1 more to get x minus 1 factorial, which is where I stop because that will cancel out with the x minus 1 factorial in the denominator. And then you're just left with the product of x plus 2, x plus 1, and x. Okay, so for the last problem, I tried to come up with something really tricky for you guys. I have an x factorial squared. So notice that I have parentheses around the x factorial and then the power of 2 on it. So that means I have x factorial times x factorial in the numerator. And then in the denominator, I have x minus 1 factorial multiplied with x plus 1 factorial. So the first thing, let's go ahead and just rewrite x factorial squared as x factorial times x factorial. Let's try to get rid of this x minus 1 factorial. Now, I know that this is simply 1 less than x factorial, so I can go ahead and expand x factorial into x times x minus 1 factorial to cancel out this guy in the denominator. Notice I carried along the x factorial over x plus 1 factorial, and then I have this x multiplied here in front. Okay, so now the larger value is this x plus 1 factorial in the denominator. It is larger than the x factorial in the numerator. So I'm going to expand it down to go ahead and cancel out the x factorial. So notice that x plus 1 factorial can be rewritten as x plus 1 times x factorial. Now x factorial over x factorial divides to 1, leaving us simply x over x plus 1. Who knew factorials could be so exciting? If you enjoyed today's lesson, if you learned something new, give this video a big thumbs up, and if you haven't already, click that subscribe button. I don't know what you're waiting for. Till next time, I'm Brett, and thank you so much for joining me.